Welcome to the Ontario High School video podcast, Density Part 3. In this series, we're going to look at finding volume when we know the mass of a substance and we know its density. We extensively discussed the traditional methodology for solving density problems algebraically, with it being a three-variable equation in the Part 2 of this series. So we're not going to talk a lot about that, other than if we want to solve using the traditional method, we're going to have to isolate volume. And the other thing that we need to do is we need to get volume up on top rather than the bottom, because if we leave volume where it is, when we go to rearrange, we're going to be solving for its inverse and not its true value. So you can see if we start with d is equal to m over v, density is equal to mass over volume, we first have to multiply both sides of the equation by volume so that we can get volume on top. And when we do that, the two volumes on the mass side will cancel, and we'll be left with volume times density is equal to mass. We still don't have volume by itself, and we want to get density to the other side so that volume can be by itself. So we then will have to divide both sides of the equation by the density. The densities on the volume side of the equation will cancel out, and so we will end up with volume is equal to mass divided by density. Well, let's do a sample problem the traditional way. The problem here is, what is the volume of a sample of gold that has a mass of 420 grams? Step 1, we're going to write a data table that reflects our knowns and unknowns. Our mass is 420 grams. Our volume is unknown to us. It's what we're seeking to find. And the density of gold is 19.3 grams per cubic centimeter. Once we have our data table, we can then write the base equation that relates density to mass and volume, and that is d equals m over v. Step 3 is that we will rearrange the base equation to solve for the unknown variable. We already did this on a previous slide. It's quite complex, but we will get volume is equal to mass divided by density when doing it the traditional way. Once we have volume isolated by rearranging our base equation, we can go ahead and plug in our numbers. So we have volume is equal to mass divided by the density. 420 grams is the mass. We divide that by the density of 19.3 grams per cubic centimeter. The grams will cancel. Your units would be 1 over cubic centimeter, which would bring the cubic centimeter up on top. And because there are just two significant figures in the 420 gram quantity, we need to round this answer to 22. So there are 22 cubic centimeters of gold in 420 grams of gold. The hope is that you've watched both Part 1 and Part 2, so this will look very familiar to you. This is the factor label conversion method. This is actually much simpler than the traditional method because you don't have to go through a lot of gymnastics in terms of equation rearrangement. So, same problem, what's the volume of a sample of gold that has a mass of 420 grams? And we do depend on the understanding of the density equality, that 1 cubic centimeter of gold is the same quantity as 19.3 grams of gold. It's the same amount. So the equality is based on the known density of gold, and it's very useful to us. Because we're treating the density as an equality, we can write two possible conversion factors. We have our 19.3 grams over 1 cubic centimeter, or 1 cubic centimeter over 19.3 grams. We use the conversion factor that's convenient for us. As before, when we do the factor label conversion method, we write down the known quantity first, then we multiply by the conversion factor that will cancel the known values unit and leave us with the unit of the quantity that we desire. So the unit we're going to is always on top in the conversion factor. The unit we're coming from is on the bottom. And the next slide will show that. So here we have our factor label conversion method problem solved. We start with our known quantity of 420 grams. We multiply it by the conversion factor that will put volume on top, 1 cubic centimeter, divided by the unit that we're coming from, which is the 19.3 grams. The grams cancel. We're left with cubic centimeters, which is a volume measurement. So we know that we set this up correctly. We have two significant figures in our measured quantity of 420 grams. The 19.3 grams does not affect our significant figures because it's a known value. It's not a measured quantity. So 420 grams times 1 cubic centimeter, we divide by 19.3 grams. Round to two significant figures gives us 22 cubic centimeters. Time for the your turn problems. What we'd like you to do is have a piece of paper and a calculator and a pencil handy and do these problems. Go ahead and pause the podcast and work these out in the method that you prefer. You can use the traditional method or the factor label conversion method. You can use the ratio method if you prefer. Remember that you have to show mathematical support for whichever method you choose with proper units labeled and significant figures, always done correctly. So go ahead and pause this, and when you're done, resume the podcast and you'll see the answers. Thanks. For problem A, we start with our known quantity, which is our mass, 300.25 grams. We multiply that times the density arranged so that the volume is on top over the mass part of the density. So it's 1 cubic centimeter over 8.96 grams. The grams cancel. We're left with cubic centimeters. There are 5 significant figures in our mass, which would be the measured quantity. So our answer must have 5 significant figures. And so we have 33.510 cubic centimeters for our answer. How'd you do? The answer to problem B, we start with our known measured quantity of 92 grams. We're going to use the density of the liquid as a conversion factor with the volume on top because it's the unit we're going to, the mass unit on the bottom, so that the grams will cancel and we'll be left with the volume measure of milliliters. So 92 grams times 1 milliliter divided by 0.785 grams. Grams cancel, left with milliliters. We need 2 significant figures here because of the 92 gram measured quantity, and our answer would round to 120 milliliters. And finally, our last your turn problem. Hopefully you're doing well with these. We have the gas with a density of 0.46 grams per liter and a mass of 12.8 grams. So we start with the quantity we know we have, 12.8 grams. We turn the density upside down to use as a conversion factor so that our volume in liters is on top and our mass unit of grams is on the bottom. That way the grams cancel. We're left with the volume unit of liters, so we know we set the problem up correctly. So our 12.8 grams times 1 liter and then divided by 0.46 grams gives us a value of 27.8 liters. So 12.8 grams of this gas would occupy 27.8 liters of volume. We've come to the end of part 3 of the density series. Stay tuned, there may be parts 4 and 5 coming as well. I want to leave you with a quote by that noted philosopher Mike Tyson: "Everyone has a plan till they get punched in the mouth."